Hello students. Today's video we are going to start with one concept which you have already studied in your class 9th. Law of conservation of mass. What does this law states? This law states that the total mass of the reactant must be equal to the total mass of the products. That means if any reaction takes place, the reactants, their mass before the reaction and the new products formed, their mass must be equal. And this is the reason why we balance a chemical reaction. To follow law of conservation of mass, balancing of the reaction is done. Now this is your important give reason question. Mark it as important give reason question. So today we are going to discuss balancing of chemical reaction. Let us begin today's topic, balancing of chemical reaction. Consider an example. Iron reacts with oxygen to give Fe2O3. Now, the number of iron atoms on the reactant side is only 1 and on the product side it is 2. The number of oxygen atoms on the reactant side it is 2 and on the product side it is 3. So, such a reaction where the atoms or molecules taking part in the reaction, their numbers are not balanced or it shows only the species involved in a chemical reaction, it is called as skeletal equation. On the other hand, if the same reaction, I represent the numbers like 4Fe plus 3O2 gives 2Fe2O3. Then such reaction will be called as a balanced chemical reaction. Now in this case, iron on the reactant side, its atoms are 4, on the product side also 4. Similarly, oxygen 6 atoms on the reactant side and 6 atoms on the product side. Therefore, it will be called as a balanced equation. So how can we define a balanced equation? Equation in which number of atoms of each element on the reactant side and product side are equal, like this one. So this is the example of a balanced chemical equation. What are the various methods by which we can balance a chemical reaction? There are two methods. One is called as heat and trial method, which is a traditional or classical method. And the second is algebraic method, or we can say algebraic balancing method. The algebraic balancing method is based on assigning algebraic variables to every species involved in the reactant. But for class 10th level, we are not going to study algebraic balancing method. We will study only heat and trial method, which is a traditional method. So let us begin with the first example. Nitrogen reacts with hydrogen to give ammonia. Now, whenever we need to balance a chemical equation, we need to find out first of all the element, its number on the reactant side and its number on the product side. So, we have only two elements here, nitrogen and hydrogen. Nitrogen on the reactant side there are two atoms, and on the product side there is only one atom. On the other hand, hydrogen on the reactant side there are two atoms and on the product side there are three. So there is a difference of one atom in both the species. Generally we begin with that species which have the least difference between the number of the atom in reactant and product. But since here both are same, we'll begin with, let's say, hydrogen. Now hydrogen on the reactant side there are two atoms and on product side there are three atoms. So I will multiply both sides, reactants and products, by such a variable, by such a factor or number which will give me the equal answer. For example, here I will multiply by 3, reactant side, and product side I will multiply by 2. The number by which we are multiplying is always written as a stoichiometric coefficient. So N2, nitrogen side, we are not making any changes, but hydrogen, reactant side, we have multiplied it by 3. Similarly, on the product side, hydrogen we have multiplied by 2. So the number which we are using for the multiplication, the factor which we have used, will be written in front and we call it as a stoichiometric coefficient. Now we will again make a tabular form whether this reaction is a balanced chemical equation or no. So now element, reactant and product. Let's say this is a step 1 and from here I will begin with step 2. So now element nitrogen and hydrogen. On the reactant side nitrogen are 2 and on the product side also it is 2. Let us talk about hydrogen. Hydrogen atoms, how we are going to calculate on the reactant side? 3 into 2, that is 6. And on the product side again 3 into 2, 6. Since the number of atoms of nitrogen is equal to reactant and product, both sides they are equal, as well as hydrogen, their number of atoms on the reactant side as well as product side both are equal. Therefore we will say that N2 plus 3 hydrogen giving 2 ammonia is a balanced chemical equation. But this pattern you will follow only when the question is asking you a detailed elaborative explanation. If the detailed elaborative expression method is not asked, then we can do it in just one step. Remember, in the final answer, all the species involved in chemical reaction, their number must be equal to reactant as well as the product side. Second example, hydrogen and oxygen combines to give H2O. Hydrogen on the reactant side there are 2 atoms, on the product side also there are 2 atoms, so there is no problem in hydrogen. But oxygen on the reactant side there are 2 and on the product side there is only 1. So I will write here number 2. In this case now oxygen got balanced, that here we have 2 atoms of oxygen on the product side as well as on the reactant side, but hydrogen got imbalanced. I have 4 atoms of hydrogen on the reactant product side and on the reactant side there are only 2. So I will multiply it by 2 and therefore this becomes the final answer. Let us go to the next example. Sodium plus oxygen gives Na2O. So while balancing, now here I can see sodium there are 2 atoms on the product side but on the reactant side only 1. So I will write here 2. For oxygen, reactant side 2 and product side only 1. So I have to multiply here by 2. So I can see oxygen has got balanced but sodium, its number is disturbed. Sodium is now 2 into 2 4 and therefore here I will change the answer towards 4. And hence the final answer will be 4 sodium plus oxygen gives 2 Na2O. Let us move towards third example. Silver chloride when exposed to sunlight will give silver and chlorine. So I will write it again. As we can see in the reaction there are 2 atoms of chlorine on the product side, therefore I will multiply it by 2 on the reactant side. In this case the silver, its number has changed and therefore I will multiply by 2 on the product side, thus giving me the perfect balanced chemical equation 2AgCl giving 2Ag plus chlorine. Moving on to a little bit complicated examples. Iron reacts with water to give Fe3O4 and hydrogen. For balancing, we will write it again. As I can see, there are 3 atoms of iron. So immediately I will multiply by 3 for iron. Oxygen, there are 4 atoms on the product side. So I will write 4 in the reactant side. I can see here hydrogen, there are 8 atoms now, and therefore I will write it here 4. So the final answer becomes 3Fe plus 4H2O gives Fe3O4 plus hydrogen. Our next example is based on balancing of complex ions, or I will say radicals. Barium chloride reacts with aluminum sulfate to give barium sulfate and aluminum chloride. How to solve such type of equations? Now have a look at the reaction once again. Sulfate, there are 3 molecules, and therefore directly I can balance sulfate at one go by writing 3BaSO4. So in the process, barium atom they have turned to be 3, and therefore barium I will make it 3 on the reactant side. But chlorine they have become 6 now, and therefore I need to balance chlorine also. So I will write it 2AlCl3. Let us check all the species involved in chemical reaction. Barium 3 atom on both the sides. Chlorine 6 atoms on both the sides. Aluminium 2 atoms on both the side, and sulfate 3 atom on both the side. So this reaction is a perfect balanced chemical equation. But always this trick do not works. Always we cannot balance the given radicals at one go. Sometimes we have to consider them separately. So it is in this reaction, in this example, lead nitrate on heating gives lead oxide plus nitrogen dioxide and oxygen. So now we will see each and every species separately. Oxygen, here there are 3 2s are 6. So 6 atoms of oxygen on the reactant side. On product side there are 2 and 2, 4 atoms of oxygen. So I will keep it aside right now. Nitrogen there are 2, and therefore I can write here 2. But in this process the oxygen has got imbalanced. Oxygen we have 2 and 2 4 plus 2 6 and 1 7. So this method is not going to work out. I will change my answer. I will write 2 with PbO. Now lead has turned to be 2. So on the reactant side I will make lead as a 2. Let us see now. 2 lead and 2 lead on both sides. Okay, it is balanced. Oxygen, 3 2s are 6 and 2, that is 12 atoms of oxygen. As I can see, still oxygen are short on the product side. So it is not a balanced equation. I will pay attention to nitrogen now. Nitrogen there are 2 and 2 4 atoms. So I will write it here 4. Now I will check everything again. Lead 2 on the reactant and product side. Nitrogen 4 on the reactant as well as on the product side. Now comes the question of oxygen. 3 2s are 6 and 2, that is 12 atoms of oxygen on the reactant side. Let us say on the product side 4 2s are 8, 9 10 and 11 12. So oxygen is also balanced, and therefore we will say this is a balanced chemical equation. This is an important example for balancing the equation. Sometimes the reaction is not given in a straight format to you, but instead a word equation is given. Let us see how to solve these statements or word equations into a balanced chemical equation. Here is the example. Natural gas burns in air to form carbon dioxide and water. Now here you must be able to click that natural gas means methane. Burns in air, that means the reaction with oxygen. Remember, whenever we say burns in air, that means it is the reaction with oxygen to give carbon dioxide and water. So as I can see clearly here, hydrogen, there are 4 atoms on the reactant side, but on the product side only 2. Therefore I will multiply it by 2 here. So hydrogen has been balanced, but oxygen, now it has become 4. And therefore, to multiply or to equalize, I will multiply oxygen by 2. And therefore, we get the final answer as CH4 plus 2O2 gives CO2 plus 2H2O. The next example is hydrogen sulfide undergoes combustion to form sulfur dioxide and water. Now undergoes combustion. This again means the reaction with oxygen. So hydrogen sulfide reacts with oxygen. Whether we say burns in air, reacts with air or undergoes combustion, it means one and the same thing, that it is a reaction with oxygen to give sulfur dioxide and water. So hydrogen is balanced on both the side, no problem. Sulfur is also balanced on both the side, that is also no issue. Problem is of oxygen. On the reactant side it is 2 and on the product side there are 3. So I will begin, I will take a random guess and I will multiply H2O by 2. So hydrogen has become 4. Let us write here 2. Here also hydrogen has become 4. Sulfur has become 2. So here I will write it as 2. Now let us check all the elements. Hydrogen 4. Here also 4. Sulfur 2 on the reactant as well as product side. Oxygen on the product side 4 and 2 6, and therefore I will write 3 along with oxygen. We call it as a stoichiometric coefficients. All these numbers which we use for the balancing of a chemical reaction, we call them as stoichiometric coefficient. So we have got the answer 2H2S plus 3O2 gives 2SO2 plus H2O. Balancing of a chemical equation is like maths. More and more you solve, more and more you will get command over it. So after watching this video, you will try to solve all the questions from NCERT. That will help you a lot. Here are some extra questions for you practice, which have included all the patterns like direct question, word equation, as well as identifying the variables. That's all for the day. Thanks for watching. Have a nice day.